Hello and welcome to the Workload Protection for Containers training video. Today we are going to overview and demo the admission control and image scanning features for containers. I am Praveen Balakrishnan. I have been with Checkpoint for 3+ years as a cloud solutions architect working on the Cloud Guard product. And a quick look at our training agenda. We are going to start it off with an overview of our workload protection suite for containers, and then we are going to dive in a bit deeper on what our admission control and image assurance feature sets can do. So our container protection basically starts at the posture management and visibility, which is basic, which is included as part of your licensing. As soon as you onboard your clusters, you'll be able to perform posture management and run container rule sets to look for vulnerabilities. But we also provide the runtime protection, which is part of the workload protection suite, where we are going to cover the image assurance and admission control today. And please refer to our other training videos for our web app and API protection, runtime protection, and intrusion detections. As with all of our feature sets, reports and dashboards are part of Kubernetes as well, where you can which can help visualize what you guys are trying to see. So the way CloudGuard workload protection works is by deploying agents as part of your cluster, and those agents have specific requirements. So for image scan add-on and the admission control, we are recommending these CPU and memory specifications. Um, which one provision will help the agents run on your cluster and perform perform the job for you guys. A quick overview of how the cluster is onboarded. Again, I will refer you guys to look at our onboarding training video, which actually shows you how you can onboard your clusters onto the CloudGuard environment. But once you have onboarded it, what's going to happen is there is going to be a checkpoint CloudGuard agent, which is going to run on the worker nodes, where it is going to start sending information back to the CloudGuard portal, where you can help visualize what you guys are trying to what the agent is actually trying to do, and give you in-depth view of your cluster and your pods and your deployment and what as part of your Kubernetes environment. So to proceed with the admission control at a high level, what it does is it's going to easily set security policies and guardrails for your cluster operations. What we are going to focus on today is the detection and the protection modes, where it can help enforce the least privilege access rights, and it can help govern cluster operations via the admission controller. So we're going to focus on that today. So I'm going to pause on the slide and go into the admission control demo, and then switch back over to the image scanning. Um, all right, I hope you guys can see that I have split my screen into two, one with the CloudGuard portal, the other with the GCP, where I have GKE, Google Kubernetes Engine, deployed with a single cluster. So now I have already onboarded this cluster as part of the CloudGuard platform. So if you go into the assets, you see that I have onboarded the environment as GKE-K8S lab, and under that one you guys can actually see that I have enabled image assurance and admission control features. So since I have enabled it, what is going to happen is you will see that the agent is deployed. The corresponding agent has been deployed for it. So I'll go do a kubectl get, and so these agents are deployed under the namespace called checkpoint. So I'm going to use the namespace as -n, and you can see that the admission controller enforcer has been deployed, as well as the image scanning agent. So these two agents have been deployed already as part of uh, the onboarding process. So since now it is onboarded, we'll work more to the workload protection, under which I will start with the admission controller, basic admission control, and with the rule sets. So by default, Checkpoint provides a default rule set with 12 different rules in it, and it has the rules uh, uh, vary with the different use cases. But for today's training, we are going to stick to a simple rule, where I have created one called the training rule. So under training rule, it is a very simple rule where I have said that the Kubernetes pod should not have containers with the image tagged as latest. It's a very simple rule, and what we're going to look for is we are going to enforce this rule using two modes. One is called the detect mode, the other is called the prevent mode. So let's get started. So how do we attach the rule set to the environment? So it has been already attached for the demo purpose, but the process is very simple. You have to click on add policy, click on environment or an OU, and then select the cluster that you want to attach, and then select the rule set, which is going to be the training rule that we have created, and the action. So these are the two different actions that I was talking about earlier. One is called the detection mode, the other is prevention mode. And so I'm going to start with the detection mode, and I'm going to attach it to a standard notification, which is going to send an email to me. I have created a simple Nginx deployment as a YAML. I'm going to show you guys um, what that deployment has as a container. So within that YAML, you can see that I am creating a container with the image of Nginx, but I have added the image as Nginx latest. So this is going to directly violate the admission control rule. So I'm going to start with the deployment, and let's see what happens. So I'm going to do kubectl create -f and nginx latest deploy. So you guys can see that the deployment has proceeded. So since the enforcement is still in the deployment, in the detection phase, it has allowed the deployment to be created. But we will, within a minute, what's going to happen is that it is going to detect, the agent is going to detect it and then send it as part of the alerts panel. Okay, before we go into the events page, let's take a look and make sure that the deployment is complete. So we will do a kube control get deploy, and you can see that the Nginx admission control training deployment has been completed. So under events, since this is a security and threat event, which is runtime, we have to check for those events under the threat and security events tab. And under there you can add a couple of different filters. So I am going to add the filter with the source as Kubernetes admission control, and I am also going to add the severity of the issue as high, because that's the category I assigned it to. And we can also add the environment just to give it more granularity. You can add the environments as well. So now we can actually see that the deployment was detected, and the image, which was the violating image, which had the tag as latest, has been detected. And since it is in the detection mode, it has been displayed here as detection. So it will allow the deployment to go through, but it will alert you on that deployment. So now we will see how it is going to be different when you actually set it up in the protection mode or the prevent mode. To proceed with that, let's go ahead and delete the deployment that we just created. So now that you can see, it has been deleted, and we will go back to the workload protection, and under the admission control policies, where we have set up the policies, let's go and edit that policy. So we can click on these three dots and click on edit policy. Now we know that we have selected the detection mode. You can see the blue outline around it, and now let's go into the prevention mode. So we'll select next, and since the notification is already saved, we go ahead and click on save. Now we can see the action here, which has changed from the detection mode to the prevention mode. Now let's go ahead and give it a minute for the agent to sync up with the latest policy information, and then try to deploy the image. Okay, so we have given the agent a minute to sync with the latest policy information, which is to switch from the detection mode to prevention mode. Now let's try to deploy the same image. So we can do cube control. uh, we can use the YAML again, and now you will see that there is an error being thrown out, that the Nginx deployment, the latest deployment, is being blocked because the admission control webhook is has denied it, stating with the GSL rule saying that the image tag should not be used should not be latest. So it's exactly doing what we have configured it to do. Now let's see if the same prevent alert has been created in our events tab. So we go back to the events, and like I said before, we go to threat and security events, under which we should be with the same filters, and you can see that you can also see the prevention mode being kicked in here and being displayed here. So that's exactly how how the admission control works. So you have created the rule, and you have created it as a policy, and now it is enforcing the policy in the prevention mode. Okay, so that actually brings us, to a close on the admission control feature. Now let's go move on to the image scanning feature. Okay, so now let's look at the image scanning. So, like I said, there are two parts to the image scanning. One is the image assurance, the image scanning at the runtime workload suite, and there is the image assurance, which is part of our Shiftleft tool. So let's take a look at how the runtime works, and then we will discuss about the Shiftleft tool. So for the image assurance at runtime, again, you can go back to your workload protection. And since we covered admission control, you can actually see there is a image assurance right up here on top. So first, I'm going to show you that how the policies actually work, because at the moment you onboard your K8S cluster, it an automatic container image assurance rule set is actually attached to that cluster, and a policy is created. So you don't have to come here and manually create a policy, which you can if you have your own rule sets that you won't attach. But the container image assurance rule set, which is created and maintained by CloudGuard, automatically creates a policy for you. And so basically, what the rule set is going to have is a bunch of different rules, but the main rule that you have to worry about is you have to worry about is image scanning rule. So there will be about like 15 different findings rules, and then there is one image scan rule. You can select the filter on that, and you can actually see the reason an image will be detected as a highly vulnerable or a critical vulnerable image if the number of critical items go above zero, above, like, even if you have one critical finding, then it's going to mark that image as a critical um, uh, vulnerable image. Or if there are a total of about 10 high findings on the image, which will automatically push this image as a critical a critical image. Basically, it has some issues which you have to immediately pay attention to and remediate. So once it has been attached, I already have a couple of different deployments running there. So you can actually see the one that um, we will do control I. You can see that there is a deployment running over here, which is called a crypto miner. And previously, we had also deployed the Nginx latest. So let's see if it got picked up already. It's again the before we it is under the events panel. So you can go into the events, and this finding, since it is image scanning, it's going to be under posture finding. So under posture finding, you can go ahead and add a filter with the category as image scan, and you can see there are two findings already. Let's see what those are, and you can actually see that the time that we deployed the Nginx image previously, when we were performing the admission control training test, it got picked up for the image scanning as well. Like I said, it will automatically get attached, and it has run it, and you can actually click on it, and you can see it has been marked as critical. That means it has at least one critical finding, or more than 10 high severity findings. So once you can click on that image, you can actually see the exact rule which has been enforced here, and you can look at the finding summary. So the finding summary says that there are about three critical image violations, or the rules which are violated on the back end for this particular image, and obviously that's automatically going to classify this image as critical severity image. So you can actually even look at the overview, and then look at the image itself. You can dive in a lot more deeper. You can look for the totals over here. It's a JSON payload where you can look at all the different CVEs. So if you want to take a look at the CVEs, you can take a look at the image itself. So you can go back to the workload protection and click on the images tab. So in here, it's going to have the all the images that is part of your part of this cluster and part of the deployment. So now we can actually add a filter and look for the environment. So basically, you can look for the environment, and you can click on the lab, the one that I'm using here, and you can see. And within here, you can actually even look for uh, you can actually even search for the image that you're looking for in Nginx. Uh, and you can see this is the one that we had just deployed. So, and it has been picked up. So let's go ahead and click on it, and it will have a detailed view of the actual image. So you can look at the overview, which is saying it is non-compliant. There is a risk score that we provide about 5.1, and then we have a breakdown of all the vulnerabilities by severity. We have 3 critical, 20 highs, and 21 mediums. So within here, we can look at the properties as well. So we can break down the asset type, the image SHA value of the image, and we can look at the entity viewer, which we already saw. So we can look at the image details. So where we have the repo that where we picked it up from, and the scan data. So this is going to be the issues, or the why you are going over the critical alerts and then the high alerts. So you can see that there are 3 criticals and 20 highs, and there are about 50 different CVEs based on the image scanning tool that we are running. So basically, that's where we picked it up from. Okay, so now that we have seen the image assurance with our runtime protection, which is during as part of our workload, let's look at the shift left side of image assurance, where we are going to use the tool to scan for images within your CI/CD pipeline or anywhere locally using our tool. So the tool can be easily downloaded from our Dome9 GitHub page. So, and it can pretty much do the same thing. So you guys can choose to block the deployment in your pipe, and plan for remediation as soon as you get the results back. So let's dive in. As you can see, I have replaced my GKE GCP portal to my uh, to my terminal tool. So I'm going to be running the shift left for locally from my Mac. We have different versions which are available for Windows, Linux, and Mac. So you can take a look at the GitHub site for the shift left tool. So as this is the site, and it has a clear installation and installation guide, and you can grab the repos based on the flavor of your operating system right over here. And we have the different use cases listed out, and how you can what are the different options that you can the flags that you can use to run the tool as well. So now that you have seen it and then you go ahead and download it, let's take a look at how we can use the tool. So this is a very common or a basic run. Basically, I'm going to run an image scan. You can see the shift left image scan has been called. As you know that we can use it for infrastructure as a code, IAC scan as well, and CFD and Terraform scan. So right now we are invoking the image scan blade, and the rule set that we're going to refer to is referred by the rule set ID. You can actually find the rule set ID by going into the image workload protection, and under image assurance you can look at the rule sets, and each of these rule sets will have their own ID. So how you are going to get the ID, you can use your APIs to fetch that, but just for the demo purposes I'm going to show you that the rule set ID is always displayed over here. So, and we actually provide the shift left command right at the top of every rule set that we have. So basically here you can invoke the tool using shift left. This is basically a bash, so it's running out of Linux. So you can run it out of call the rule set over here using the rule set ID, and you can now specify the environment where you want to send the results back to. So basically what's going to happen is once you're going to go through the shift left setup, so it will ask you to set it up in such a way that you have an API key and secret created for your domain or the CloudGuard portal, from where you can actually use those keys to actually upload those results that you're running locally or on your CI/CD pipeline back into the CloudGuard portal. So basically, use the API keys to send the information back. So creating the API keys, you should refer back to our tutorial on how to create it. It is pretty straightforward, where you have to just create a service account and then create a API key and secret, and you can use that. So once you have done that and set up your environment to refer to those API keys and secrets, you can now call the -e flag, which will basically use the shift left environment ID. So you can actually fetch this environment ID by going into your assets, going into your environments, and then obviously this is going to be part of my GKE. So I'm going to choose this guy, and you can see the CloudGuard ID, which is called the environment ID, referred over here. And basically now we are going to point to the tar file, basically your image file, which is in a tar format, and you go ahead and invoke the tool. So let's go ahead and scan it. So as you can see, it has updated the image automatically. Every time that we invoke, it's going to update to the latest version. It will make a call to a repo and update it. So earlier it used to be 0.0.34. Now it is upgraded it. And the image scan blade has been invoked. So since we are using image scan over here, it has invoked that particular blade, and the scan has started. And you can see the scan results coming down. So this is pretty much what how we can fetch the report using the CLI. So it's going to have all the CVEs listed out for that particular image that we scanned. It's a crypto image. It's similar to the one that I had deployed on my GKE cluster earlier and it's going to have a detailed breakdown of all the project name and the CVE and how it is scanned, and all the CVEs listed out as pertaining to the image. And the same results would have been uploaded back into the CloudGuard portal, since we have provided I have provided set up my shift left tool with the API keys and secret. And so to look at the results in the UI, So you can go back to the events and posture findings, and you should be looking at the image scan here as well. And so you can see that this has come through. So let's take a look at the time stamp. So this was run, just invoked right about now. So you can see that this was the scanning which was run, and obviously this is the same image that we had used previously as well. But obviously, um, um, uh, we are going to this was fetched using the shift left tool. So all of the information is over here as well. So you can look at the image and the remediation summary. So basically, you have all the CVEs listed out over here. So it's going to correlate to the number of CVEs found over here. So that's exactly how we fetch it. And we also have the remediation summary. So how we want to, if there is malicious files in there, we will be asking to remove that file, or if there are commands which needs to be updated, so which you guys can it can be updated as well. And we have a finding summary. So we have obviously the critical count, which is going to 24, that has automatically marked this image as a highly critical severity image. So at a high level, this is how the shift left tool works for image scanning. I'm hoping that you guys enjoyed this session. So we will create a many more of these sessions for our container security. So next time we will be working on the threat intelligence for containers, and we will also look at the runtime protection. Thank you so much for listening to this training video.